Hello everyone. So let's now solve question number 3 from practice assignment week 2. So question 3 says choose the set of correct options. So for checking the correctness of these options, we will be using some formulas and properties of adjoint and cofactor of matrices, and we'll either try to disapprove them or prove them using these properties and formulas. So let's see how we are going to use them by checking each option one by one. Option 1. So option 1 says if A is a upper triangular matrix of order 3 cross 3, then the adjoint matrix of A is also an upper triangular matrices. Now, adjoint for any matrices is given by C transpose, where C transpose is the transpose of cofactor matrix of A. So, let's say we have any upper triangular matrix of order 3 cross 3 A. Any upper triangular matrix for order 3 would be in this form, where all the entries below the main diagonal would be 0. Now, if we want to find the cofactor matrix of this, then for any ijth entry in the cofactor matrix, it denotes the cofactor at ijth entry for matrix A. And we can find the cofactor by using the formula, that is minus 1 times minus 1 power I plus j times minor at ij, where mij denotes the minor of the matrix at ijth point entry. So, for example, if we are finding the cofactor matrix entry at 1 1th entry, that is first row first column here, then we will eliminate these rows and columns. We'll get a sum matrix. We'll find its determinant. So its determinant would be d dot f, and we will multiply with minus 1 power I plus j. So here we are finding it 1 1th entry, that is 1 plus 1 2, so that is d dot f. So first entry for cofactor matrix would be d dot f. Similarly, we will try to find each and every entry. So now if we are finding first row, second column, so we'll eliminate these rows and column. We'll get a sum matrix that contains this, 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 this. The determinant of this matrix is 0. So anyway, it will be 0. Similarly, for third, it is also 0. Now along this, the determinant is b dot f, and as it is a second row first column, okay, so this entry is second row first column, so minus 1 will be of power 3, so that would be minus 1, so it would be minus b dot f. Now second row second column, it would be a dot f, and second row third column, then it would be 0. Now third row first column, so it would be be minus dc, and 3 plus 1, that is 4, so even power. Now third row second column, so af, so sorry, ae minus 0, so ae, but it would be negative power, so minus a dot e, and for third row third column, it would be just simple ad. Okay, so now we have to do the transpose of this matrix. So C transpose would be, the rows will become column and the column will become rows. So for example, this first column will become the row of this matrix C transpose, E dot F minus B dot F, BE minus DC. Similarly, the second column will become the second row, 0, A dot F minus A dot E, and the third column will become the third row, A dot D. So one can clearly see that this is also an upper triangular matrix as the elements above the diagonal are non-zero while these are 0. So it is an upper triangular matrix, and the first option would be correct. Now the second option says if A is an upper triangular matrix 3 cross 3, then the inverse of matrix of A is also an upper triangular matrix. Now if we want to find the inverse of a matrix using adjoint method, then A inverse is nothing but adjoint of A divided by determinant of A. Now we are going to use the above matrix as same. Option 2. Now we go this matrix as our adjoint of matrix A here, and we have taken A to be our upper triangular matrix. So simply A inverse here would be adjoint of A divided by determinant of A, adjoint of A. Our adjoint of A was an upper triangular matrix. If we are going to divide it by some determinant, then again it will be an upper triangular matrix. So that's why the second option would also be correct, because our adjoint of A is already an upper triangular matrix. Even if we divide it by some scalar, determinant of A would be some scalar quantity. So even if we divide it by its scalar, it will still remain in its upper triangular form. So that's why option 2 is also correct. Now let's look at option 3. Option 3 says let A be an arbitrary real 3 cross 3 matrix. If C is the adjoint matrix of A, then C is also the adjoint matrix of A transpose. So let's check that. Option 3. So for it, we will consider some matrix, let's say A, as follows. Now, if we try to find the adjoint of this matrix, so let's first simply calculate the cofactor matrix quickly. So this is the cofactor matrix. Now if we do the transpose of cofactor matrix, that gives us adjoint of matrix A. So it would be 0, 0, minus 1, 0, 0, 0, 0, 0, 0. So this is the adjoint for matrix A. Now we have to check for whether this is also the adjoint for A transpose. Right? That's what it is asked in option 3, that if C is the adjoint of matrix A, then C is also the adjoint for matrix of A transpose. So let's calculate first A transpose. So A transpose would be this 1, 0, 0. And let's try calculating the cofactor matrix. This will be the cofactor matrix. We will using the same method that we did before for calculating cofactor matrix. Now transpose of cofactor matrix. So this will be our adjoint matrix for A transpose, and we can check that these two are not same. The matrix here and here are not same. So if C is the matrix for adjoint of matrix A, then C is not the adjoint matrix for A transpose. So option 3 is wrong. Now let's check option 4. Cjk denotes the cofactor with respect to the ijth, with respect to jth row and kth column of a 3 cross 3 matrix. If another matrix B is obtained from A by replacing the jth row of A with 3, 0, 0, then determinant of B is 3 times Cjk. So let's look at option 4. So Option 4 is that Cjk denotes the cofactor with respect to jth row and kth column for some matrix A. Now, if another matrix B is obtained from A by replacing the jth row of A with 3, 0, 0, then determinant of B is 3 times Cjk. So let's consider some matrix A. That is to be our identity matrix. Now Cjk denotes the cofactor at jth row kth column. That's j is equal to 2 and k equal to 2. That is the second row, second column. That is this entry. So if we are going to calculate the cofactor at this entry, it would be simply 1. Now, what would be our matrix B? B is the matrix that is obtained by replacing the jth row, that is the second row, as we are considering j equal to 2. So if we replace the jth row with the 3, 0, 0, then they are claiming that the determinant of B is equal to 3 times Cjk. And our Cjk was 1. That means determinant of B should be equal to 3 for option to be correct. But is it really the case? So let's try calculating the determinant for this matrix. We have one property of determinant, that is if the any row or column of a matrix is 0 row or 0 column, then the determinant for that matrix is 0. So from that we got that determinant of B is 0 and not is 3. Hence this option is also incorrect. As sometimes it is easier to disapprove some statement than proving it, and for disapproving a statement, we only need one counter example that does not follow the rule that is stated in the option. So that's why sometimes we use some option to disapprove a statement. Now let's check option 5. Now option 5 says if A is an invertible 3 cross 3 matrix and C is the adjugate of A, then determinant of C is determinant of A power 9. So we have one properties already, that is determinant of adjoint of A is equal to determinant of A power n minus 1, where n is the order of the matrix. So we'll first derive this formula, how this formula came. So we have that adjoint of A, sorry, A inverse is equal to adjoint of A divided by determinant of A. Now we can also write it as adjoint of A is equal to determinant of A times A inverse. If we take determinant both sides, then determinant of adjoint of A is equal to determinant of A times A inverse. Now this determinant of A is technically some scalar number. Okay, so for that, let's denote this determinant of A to be some k. Okay, as it is a some scalar number and it is getting multiplied to this matrix A inverse. A inverse would be of the same order for which our matrix A is. So they A and A inverse will be of same order. So by using the properties of determinant, this would be k that we have represented as determinant of A power n, where n is the order of the matrix. Okay, times determinant of A inverse. Now again just replace with, I am replacing it with determinant of A so that we have everything in determinant of A terms. Now determinant of A inverse is simply 1 by determinant of A. So we got determinant of A power n minus 1. That is our determinant for adjugate of matrix A. So that's how we got this formula. And in the option it is defined that determinant of C is equal to determinant of A power 9, where C is adjugate of A. So C is adjugate of A. So the determinant of C would be determinant of adjugate of adjugate of A. So determinant of this would be determinant of A power n minus 1 whole square. As we are taking 2 times adjoint, so it would be just the square of that. Now, for checking this, let's use some example to check whether it is really the case or not. So, we have an example that is A equal to if matrix 0, 3. Then I will just simply directly write the adjoint of matrix A. So this is for our adjoint of matrix A. If we try calculating the determinant of adjoint of matrix A, then now check that this is then diagonal matrix. So for the diagonal matrix, its determinant would be the product of its diagonal entries. So that would be 6 into 3, 6 to the 18 to the 36. While what was our determinant of A? Determinant of A was 6. As it is also a diagonal matrix, so product of its diagonal entries will give us determinant. So determinant of A is 6. Determinant of adjugate of A is 36, that is 6 square. That is determinant of A power n minus 1. Determinant of now A is our 3 cross 3 matrix, so it would be determinant of A square, that is 36. So that is correct result. Now if we again try, then adjugate of A, so this would be 18. Now what would be this determinant? Adjugate of A is 6 times 12 times 18, and that is equal to 6 power 4, and that is determinant of A power 4. Okay, and we can also write it as determinant of A power n minus 1 square. Okay, so the result that we got above was the correct, and hence as it is not equal to determinant of A power 9 that is given in the option, so this option is also incorrect. Okay, thank you.